Hello students, this is Dr. Anita Raj, your chemistry mentor, welcoming you for another session in electrochemistry. In this session, we shall see the Faraday's laws of electrolysis, okay? Actually, the relationship between the quantity of electric charge passed through an electrolyte and the amount of substance deposited at the electrodes was presented by Faraday in 1834 in the form of laws, okay? Those laws are called as the Faraday's laws of electrolysis, right? So we have two laws proposed by Faraday. That's the Faraday's first law and Faraday's second law. Okay. So we shall move into the topic right now. Faraday's first law states that when an electric current is passed through an electrolyte, the amount of substance deposited is proportional to the quantity of electric charge passed through the electrolyte. Okay. So actually Faraday's first law states that when electric current is passed through an electrolyte, the amount of substance that is getting deposited in an electrode will be directly proportional to the amount of current that we are passing through the electrolyte. Can you understand? So let us consider if W is the mass of the substance deposited. If W is the mass of the substance deposited by passing Q coulomb of charge, then according to this law, we have the relationship as W is directly proportional to Q. That is, according to Faraday's first law, the amount of substance getting deposited will be directly proportional to the coulomb of charge that we are passing. Okay. So what is a coulomb? Right? A coulomb is the quantity of charge when a current of 1 ampere is passed for 1 second. What is coulomb? What is coulomb? It is the quantity of the charge when a current of 1 ampere, okay, when a current of 1 ampere is passed for 1 second. So that is called as coulomb. Okay. The amount of charge in coulombs is Q is equal to current in amperes. Okay, current in amperes into time in seconds. Okay, time in seconds. Understood? So this is equal to what is current in ampere? We can give the simple I. Okay, I into T. Understood? I into T. If Q is I into T, then W will be proportional to I into T. Can you understand? So W is equal to it's proportional to I into T. Can you understand? Current in amperes into time in seconds. Okay. So now we are going to remove this proportionality sign by a constant and an equal to sign. Okay. So W is equal to, so we are introducing a constant Z into I into T. Can you understand? So what is a Z? Z is a constant known as electrochemical equivalent. What is a Z? Z is nothing but it is electrochemical equivalent. Electrochemical equivalent. Okay. So it's nothing but it's electrochemical equivalent and its characteristics of a substance that is getting deposited. Okay, it depends upon the characteristics of the substance that is getting deposited. See, when a current of 1 ampere is passed for 1 second, then Q will be equal to 1. Am I right? If a current of an ampere is 1 and it is passed for 1 second, then Q will be equal to 1. In that case, W will be equal to Z. Am I right? If Q is equal to, that is I into T is 1, then W will be equal to Z. Is it not? So, if Q is equal to 1, then W will be equal to Z. Is it not? W will be equal to Z. Thus, electrochemical equivalent can be defined as the mass of the substance deposited by 1 coulomb of charge. Okay, or when 1 ampere of current is passed for 1 second. Can you understand? Electrochemical equivalent is nothing but it is the mass of the substance deposited by 1 coulomb of charge or by 1 ampere of current passed for 1 second. Can you understand? So thus this Faraday's first law has been proved. Okay. For example, when a charge of 1 coulomb is passed through silver nitrate solution. See, let us consider silver nitrate solution, okay, AgNO3 solution. When 1 coulomb of charge or 1 ampere of current is passed for 1 second, then the amount of silver, that is amount of silver deposited will be equal to 0.00118 grams. So this value is actually nothing but it is the electrochemical equivalent of silver. Okay. So this much amount of silver will be getting deposited over the electrode when 1 coulomb of electric charge is passed or 1 ampere of current is passed for 1 second. Can you understand? Now let us see the Faraday's second law. Actually, when same quantity of charge is passed through different electrolytes, then the masses of different substances deposited at the respective electrodes will be in the ratio of their equivalent masses. Can you understand? See here, when same quantity of electricity is passed through different electrolytes, 3 different electrolytes were taken: dilute sulfuric acid, copper sulfate solution, silver nitrate solution. Okay, so 3 different electrolytes are taken and equal amount of electricity is passed through or equal amount of charge is passed through all 3 these different electrolytes. So what happens is the substances will be getting deposited on the surface of the electrodes. Here in sulfuric acid, hydrogen will be getting involved. In copper sulfate solution, copper will be getting deposited on this electrode. And in silver nitrate, the silver will be getting deposited on this electrode. Okay. So then what will happen when same quantity of electricity is passed? The masses of different substances getting deposited at the respective electrodes will be in the ratio of the equivalent masses. That means the amount of substance getting deposited will be equal to the equivalent masses. So this is what Faraday's second law says. Okay. So see, according to the second law, when we are taking this ratio, mass of hydrogen divided by mass of copper will be equal to equivalent mass of hydrogen divided by equivalent mass of copper, or mass of copper divided by mass of silver will be equal to equivalent mass of copper divided by equivalent mass of silver, or mass of silver divided by mass of hydrogen will be equivalent to equivalent mass of silver divided by equivalent mass of hydrogen. Okay, so it is observed that by passing 1 coulomb of electric charge we will be getting, I told you earlier, hydrogen will be getting evolved here. So how much amount of hydrogen will be evolved? It will be equivalent to 0.0001036 grams. Okay, how much amount of copper will be getting deposited? It will be 0.0003292. Amount of silver will be getting deposited. It is 0.0011118 grams. Okay, so actually these are the masses. Okay, these masses are in the ratio of their equivalent masses. See, from these masses, the amount of electric charge required to deposit 1 gram equivalent of hydrogen or copper or silver can be calculated. Can you understand? So these are the masses that are getting deposited. From these masses, the amount of charge or electric charge required to deposit 1 gram equivalent of hydrogen, copper or silver can be calculated. How we can calculate for hydrogen? Let us see how to calculate for hydrogen. See, for hydrogen, it's equal to 1 divided by 0.0001036. So that's equal to 96,500 coulombs. Okay. So that's if you calculate for copper, it is 31.78. Okay, 31.7. It is nothing but it is the equivalent weight of copper. Okay, divided by 0.000392. That's equal to again 96,500 coulombs. Okay, if you are looking for silver, it would be 107. Equivalent weight is 107.88 divided by 0.001118 is equal to 96,500 coulombs. Okay, again, right? So this follows that 96,500 coulombs of electric charge will be deposited by 1 gram equivalent of any substance. Can you understand? So the amount of electric charge will be deposited by 1 gram equivalent of any substance. Okay. So this 96,500 is termed as 1 Faraday and is denoted by F. Okay. It is nothing but 1 Faraday. Okay. 1 Faraday. And it is denoted by the simple F. Okay. Capital F. So again, according to first law of Faraday, W is equal to, say according to the first law, okay, according to the first law, W is equal to Z into Q. It is not. So according to Faraday's first law, W is equal to Z into Q. Where Q is nothing but, it is 1 Faraday, that is 96,500. Okay. So Q is equal to 96,500. Okay, Q is equal to 96,500 and W, that is mass of the substance, is equal to gram equivalent mass. If it is gram equivalent mass, that is E, then this equation becomes E is equal to, okay, E is equal to Z into 96,500. Okay, Z into 96,500, or Z is equal to, that is Z is electrochemical equivalent will be equal to E divided by 96,500. Okay. So now let us consider if Z1 and Z2 are the electrochemical equivalent of two substances A and B. Okay. So let us consider that Z1 and Z2 are the electrochemical equivalent of two substances A and B, and E1 and E2 are the gram equivalent masses of the same substances respectively. Then Z1 will be equal to E1 by 96,500 and Z2 will be equal to E2 by 96,500. If so, then Z1 by Z2 will be equal to E1 by E2. Okay, so hence proved, right? Hence the Faraday's second law has been proved. Z1 by Z2 is equal to E1 by E2. Can you understand? Well, fine students, I hope you might have understood what I have taught today. Let me meet you with another important topic in my next session. Until then, it's Dr. Anita Raj, your chemistry mentor, signing off from you. Thanks for watching.